Welcome to qnawire.
All right, so this question is really tricky. I consider it sort of like a challenge question because it goes against everything that we kind of know about carbon, which is that it really only wants to form 4 bonds. And that's because when you pump a whole bunch of energy into it, you can get these weird combinations. So we might be tempted to start with something like this, just drawing 5 bonds to carbon, like that. And then throwing a positive charge on it and calling that good. But the issue with this is that carbon has 4 valence electrons, hydrogen each has 1, so that gives us 9 total, 4 plus 5. And then with this positive charge, we only have 8 electrons to work with. And here I've drawn in 10 electrons, so 5 bonds, each with 2 electrons. So this guy cannot possibly be our answer. So what the answer ends up being is it's a CH3 group, a kind of regular CH3, that's forming a bond to a hydrogen gas molecule, so an H2. And this is one of those cases where bonds are traditionally between 2 atoms and 2 electrons. However, in this case, the bond is between 3 atoms and 2 electrons. So these sort of dashed lines indicate that these aren't 3 bonds, but rather 1 bond that's sharing 2 electrons. This whole thing needs a positive charge. And so what would we call this hybridization? So it's got these 3 regular bonds. That'll be sp2, and it's the p orbital that actually interacts with these guys. So 3 bonds of even energy are these guys, and then the other bond formed that you would normally form a p orbital with is the p orbital interacting with the hydrogen gases orbital. The geometry of this is sort of like a pseudo tetrahedral, right? If this was just one thing, this H2 unit was just one object, it would be tetrahedral. But because it's not, it's sp2. This is actually trigonal pyramidal. So these guys would be trigonal planar here, and then it's got a cap on it.